Hello viewers, welcome to this 32nd module of the MOOC course in econometrics on the topic called dummy variables. In this topic, we will study qualitative regressors. In a regression equation till now, we have denoted the regressors by the variable x, where x generally denoted a quantitative variable, a variable that can be quantified or measured. Now, we will look at qualitative variables. So, let us write a simple regression equation in the form of y I equal to beta 1 plus beta 2 x I plus u I. This is our familiar regression model, but now we are going to posit x as a qualitative variable. For example, if y is salary, then x could be the level of education. So, we are trying to see whether the level of education makes any difference as far as the salary of an employee is concerned. Education can be measured in two ways. One, number of years of education, but better still, we can take different levels of education. For example, we have graduates and undergraduates. So, we are trying to inquire whether there is a difference in the salary of employees depending on whether they are graduates or undergraduates. Accordingly, we use the variable E in place of x. We could have jolly well denoted it as x, but just because we are writing education, so this variable E will replace x, and because we cannot really measure graduate, undergraduate in the sense of a number line, we say that if the person is a graduate, the dummy takes the value 1. If the person is an undergraduate, then the dummy takes the value 0. So, E will take either value 1 if the person is a graduate, or it will take the value 0 if the person is an undergraduate. Accordingly, we write our regression model as y I is equal to beta 1 plus beta 2 E I, where E I will be 1 for graduates and 0 for undergraduates. So, how do we interpret this model? If we take the expected value of y, then expectation of y given E is equal to 0 means this value of E will be 0 and expectation of u I, as we know, is 0. So, therefore, expectation y I given E I equal to 0 will be only beta 1. So, that is the mean salary of undergraduates, because we are putting 0. So, this beta 2 effect has gone. So, this regression tells us that the mean value of undergraduate employees is beta 1. Similarly, if we had considered the expected value of y given that the education level is represented by dummy value equal to 1, then we would get beta 1 plus beta 2 plus expectation of u I, which is 0. So, that would give us beta 1 plus beta 2. So, what is the interpretation of this model? If an employee is an undergraduate, the mean salary is beta 1. If the employee is a graduate, then the mean salary is beta 1 plus beta 2. So, what is beta 2? It is the differential or incremental effect of being a graduate. It is the differential or incremental effect on the salary because the person has become a graduate or because the concerned person is a graduate. One more thing that we have to keep in mind is, if, as in this case, we have one particular feature that we are trying to capture, that is, we are trying to capture the effect of the education level, and if there are two possibilities, if there are two possibilities 1 and 0, then we keep one dummy variable. Two possibilities, we keep one dummy variable. Why we are doing this will become very clear when we expand this model to incorporate higher levels of education. We can explain it with this model, but in a few minutes time we will go for an expanded model and we will explain why we have for two particular possibilities only one dummy variable. In the example that we just now saw, we considered one qualitative variable, that is education, which had two possibilities or two categories. For two categories we had taken one dummy variable. Let us now expand the possibility of the categories of the dummy variable education. So, education, now we are considering undergraduates, graduates and postgraduates. So, we will now consider two dummy variables E2 and E3. Of course, implicitly there is this possibility E1. So, in the regression model, however, we will write y is equal to beta 1 plus beta 2 E2 plus beta 3 E3 plus u, and we put the subscript I for the ith observation, that is I running from 1 to up to n. So, what is the meaning of this model? So, when the person is a graduate, but not a postgraduate, we say 1, and so these two are, this is therefore 0. And when the person is a postgraduate, that is beyond a graduate, we put 0 and 1. So, E2 will be 1 for people who are just graduates, only graduates, and E3 will be 1 for person who are postgraduates. So, E3 1 if it is a postgraduate case, otherwise 0, E2 1 if it is a graduate, otherwise 0. So, now let us take a look at what the implication of this model is. And remember, implicit in the model is a possibility, a category E1 of undergraduates, which is not being explicitly shown in the model. So, expected salary, given that the person actually is an undergraduate, that means both of these are 0. So, if the person is an undergraduate, then neither a graduate nor a postgraduate, so both of these are 0. So, that means that is equal to beta 1. Please take a look once more. If the person is neither a graduate nor a postgraduate, then we can neither put 1 for E2 nor 1 for E3. E3 is 1 if and only if the person is a postgraduate. E2 is 1 if and only if the person is a graduate. So, we put 0 and 0, and therefore, it boils down to expected salary equal to beta 1. So, this is like the base salary. So, this is the mean salary of undergraduate employees. Expected value of y, given that E2 equal to 1, this is E1 equal to 1. Of course, if this is 1, then both are 0. If this person is an undergraduate, that means neither graduate nor postgraduate. So, this case, if E2 is equal to 1, then beta 1 plus beta 2. So, this is the mean salary of graduate employees. Just to recall very briefly, if we regress y on x2 and x3, and if we say that x3 is equal to lambda x2, then if we replace x3 by lambda x2, the model becomes yi is equal to beta 1 plus beta 2 x2 plus lambda beta 3 x2. So, beta 3 becomes x3 becomes lambda x2, and therefore, we actually get a model with only two explanatory variables. So, we cannot estimate beta 2 and beta 3 separately if we have perfect collinearity or multi-collinearity. The same thing happens if we write beta 1 plus maybe alpha 1 E1I plus alpha 2 E2I plus alpha 3 E3I plus UI. So, if we had modeled the earlier example in this fashion, where we had brought in all the three education levels, then as you know, for the intercept the values of the x are always 1. For education level E1, that is undergraduate, we write 1 and 0 0. If the person is a graduate, we write 1 0 and 0, and if the person is a postgraduate, we write 1 0 and 0. But viewers, recall the very first introductory modules where for the intercept terms all the x's are 1. So, this matrix is like the X matrix, where X has 1, 2, 3, 4 columns. So, this is x1, x2, x3, x4, and what you can see now is if you add up column 4, column 3 and column 2, then you get exact replication of column 1. So, if you add up all these 3 columns, 0 plus 0 plus 1, that gives 1, 0 plus 1 plus 0, that gives 1, 1 plus 0 plus 0, that gives 1. In other words, variables E2, E1, E2 and E3, if you add these up, it becomes the same as the variable x1, which is the intercept. Therefore, we cannot get the determinant of this x, and therefore, we cannot get x prime x inverse. Sorry, you cannot get the determinant of x prime x, and therefore, we cannot get x prime x inverse. But we know that beta hat is equal to x prime x inverse x prime y, and this x prime x inverse requires the determinant of x prime x, but that determinant will not be calculable, because x prime x, the determinant cannot, actually it becomes 0, this determinant will become 0. If there is perfect multi-collinearity, then this determinant becomes 0. So, we cannot calculate x prime x inverse. In other words, we cannot get all the elements of beta, beta 1, beta 2, beta 3, beta 4, or beta 1, alpha 2, alpha 3. We cannot get them separately. Just like earlier in the simple example, I had shown you that x2 is equal to lambda x3 means we cannot get beta 2 and beta 3 separately. We will get one compact beta 2 plus lambda beta 3. So, this is the problem that we encounter if we bring in an intercept together with all the 3 categories, all the 3 possibilities. What is the way out? Yes, we can have 3 dummy variables for 3 levels of education, but then we have to drop the intercept. So, that is a model which is once again okay, because we do not have the intercept term. So, that is the way out. Either for 3 possibilities you have 2 dummy variables and an intercept, or the model does not have an intercept. Here you can have the 3 categories, that is undergraduates, graduates and postgraduates, and we can estimate the model. What do we do with such models? So, we want to really test whether post graduation leads to a salary hike. Of course, it would depend on the nature of the job. So, what do we say? That H naught, which is the post graduation factor, E3 alpha 3. So, we test H naught alpha 3 is equal to 0 against H naught alpha 3. Either we can say not equal to 0, which is a two-tailed test, or we can say greater than 0. And we can carry out the same test procedures as we had seen in the module on testing of hypothesis. Now, we will extend the model to bring in another qualitative aspect, that is, together with education, we will look at the effect of a gender difference. So, let us now consider another qualitative variable, say the gender of a person. Oftentimes, we say that in the workplace there is something called gender bias. So, now we are saying education could be E1, E2, E3, this is undergraduates, this is graduates, this is postgraduate, and the gender we can write as S1, S2. Say this is female and this is male. So, we are considering three levels of education: undergraduate, graduate and postgraduate, denoted as E1, E2 and E3, and two genders, male and female, denoted by S1 and S2. As earlier, if we incorporate an intercept term, then the model would be like y is equal to beta 1 plus, remember we have to avoid the dummy variable trap. So, we take only 2. So, we take beta 2 E2 plus beta 3 E3. Similarly, for this qualitative variable which has two categories, two possibilities, we will take only one. So, we say plus beta 4 S2 plus u. So, for the ith observation we write yi, E2i, E3i, S2i, ui, or even simpler we could have just written S because we have one S. So, we can just write S. So, what is the basic idea behind this model? What is beta 1? For beta 1 all of these are 0. If the person is just an undergraduate male means E2, E3 and S2 are all 0. So, this is the base salary of an undergraduate male employee. Keeping the person's gender intact, that is male, if the person considered now is a graduate, then beta 2 is the additional impact of graduation. Third level, if we go to post graduation, then beta 3 is the impact of post graduation. So, this is a graduate male. For a graduate male, this is the differential impact. So, you add beta 2, you have beta 1 plus beta 2. Viewers, now we will incorporate dummy variables in a model where we have quantitative regressors as well. So, we begin with y being regressed on a variable x. So, yi beta 1 plus beta 2 xi and ui. And needless to mention, the estimated relation or the population regression would look something like this. So, that is the intercept and the slope is shown by the measure of the tangent of this angle theta. So, tan theta is the slope of this line. Now, it may so happen that there are two regions, say northern region and southern region. There are two regions where we have the same model being applied, and there are reasons probably to believe that in the southern region the slope could be different from the slope in the northern region. So, I repeat, the same basic model may be applicable to two different regions of a country, northern region and southern region, and there may be reasons to believe that the slopes of the regression lines are different. In that case, what we do is we add or bring in a dummy variable di xi plus ui. So, what about the dummy variable? If the observation is in the northern region, we write 1, otherwise we write 0. And see, there are two possibilities, two categories. So, D or maybe R, whatever, sometimes we can write R as the region, dummy region. So, this D takes, it has two possibilities, northern 1, southern 0, but only one is incorporated here, the other will be taken care of by the intercept. So, what do we make of this model? We say that expectation of y when D is equal to 0, that is beta 1 plus beta 2 x or yi, that is xi, and expectation of yi when D is equal to 1, that would be beta 1 plus beta 2 plus beta 3 xi. So, viewers, you can see that now for the southern region, that is when D is 0, south means D is 0. So, for the south this is the regression. For the north, what is the difference? The difference is the intercept remains the same, but the slope has changed. So, we are considering we are supposing that beta 3 is positive, so that you have another regression like that. So, these are two regression lines for the two regions. This is the base, the south, this is the north. So, what is beta 3? Beta 3 is the incremental effect of being in the northern region over being in the southern region as far as the slope of this regression is concerned.